Hello everyone, my name is Jensen, and today I will be presenting on thyroid hormone status was associated with obesity in adolescents aged 12 to 19 years in the United States, data from National Health and Nutrition Examination Survey, or NHANES, 2011 to 2012. My committee members are Dr. G, Dr. Hawk, and Dr. Belay. Obesity is a complex physiology that is on the rise globally. Thus, it is important to understand this physiology further. Obesity is defined by the World Health Organization as abnormal or excessive weight accumulation that may impair health. In the United States, 21.2% of adolescents aged 12 through 19 were obese in the 2017 to 2018 year. While the prevalence of obesity is increasing, researchers still do not fully understand the causes of obesity. There is a wide range of known factors that contribute to obesity, including but not limited to behavior, environment, genetics, and social factors. Some studies have indicated that thyroid-stimulating hormone, or TSH, and triiodothyronine, or T3, are elevated in obese children. Other studies have found no significant differences in thyroid hormone status between non-obese and obese individuals. Studies that have been done on thyroid hormone status of adolescents also often do not represent the adolescent population of the United States. There is no consensus on the significance of thyroid hormone status on obesity. Therefore, the purpose of this study was to investigate relationships between thyroid hormone status and obesity in adolescents aged 12 to 19 years in the United States, with data available from NHANES. Thyroid hormones are a key factor in regulating basal metabolic rate and may contribute to the development of obesity. There are three main ways that the body expends energy: dietary thermogenesis, physical activity, and BMR. It is estimated that 60% of total daily energy expenditure in sedentary adults is from BMR. The thyroid gland produces two main hormones that are used by the body to increase BMR. These hormones are triiodothyronine, or T3, and thyroxine, or T4. T3 and T4 increase BMR by stimulating activity and expression of sodium-potassium pumps in various tissues. This increased activity and expression of sodium-potassium pumps increases oxygen consumption, respiration rate, and body temperature. In addition to T3 and T4, there is another important hormone involved in metabolism called thyroid-stimulating hormone, or TSH. However, TSH is not produced in the thyroid gland, it's actually produced in the pituitary gland, but it still stimulates production of T3 and T4 in the thyroid gland. Iodine is also required to synthesize T3 and T4, and iodine is a micronutrient that's found in bread, iodized salt, milk, and marine wildlife. Another important micronutrient in thyroid hormone processes is selenium. If a T4 molecule is produced in the body, it can be converted into T3 by an enzyme called deiodinase. And deiodinase is a selenium-dependent enzyme. Impaired thyroid hormone synthesis can occur if the body is selenium deficient because there's just not enough deiodinase being produced. For this study, we used data from the National Health and Nutrition Examination Survey 2011 to 2012. We used this year because this was the most recent information available on thyroid hormone status. We had 355 adolescents aged 12 to 19 in our sample. Abdominal obesity using waist circumference was defined as greater than 87.5 centimeters for males and greater than 87.2 centimeters for females. Abdominal obesity using BMI was defined using CDC BMI for age charts. The data was analyzed using SAS version 9.4. All skewed data was log transformed before analysis. Multiple linear regression analysis was used to determine predictors of BMI and waist circumference. Statistical significance was declared if P was less than 0.05. Table 1 shows the characteristics and thyroid hormone status of adolescents. The total number of adolescents in this study with thyroid hormone data was 355. Most of the subjects had normal TSH, thyroglobulin, total T3, and total T4 levels. Of the adolescents, 0.2% had low TSH or low total T3, 2.3% had high TSH, 2.5% had high total T3, 8.4% had high thyroglobulin levels, 15.7% had high urinary iodine concentration, and 33.3% had insufficient urinary iodine concentration. In addition, 6% of adolescents had very low food security, 14.5% had low food security, and 49.4% of adolescents' families made less than 130% of the Family Monthly Poverty Index. Figure 1 shows the percentages of adolescents for BMI and waist circumference categories. Over half of adolescents had a normal BMI or normal waist circumference. Based on BMI classifications, 15.9% of adolescents were overweight and 21.71% were obese, and only 2.9% were underweight. Of the adolescents, 37.7% had a high waist circumference. In Table 2 and 3, results from the best fitting multiple linear regression model with 10 predictor variables for BMI and waist circumference were presented. The variables included were socio-demographic, family poverty level, physical activity level, and thyroid hormone biomarkers. Among these, 5 variables were significant predictors of BMI, and 3 variables were significant predictors of waist circumference. A 1-hour increase in use of computer was associated with a 0.71 kilogram per meter squared increase in BMI. Each log unit increase in family poverty level resulted in an increase of 2.18 kilogram per meter squared in BMI and 5.15 centimeter in waist circumference. Moreover, both BMI and waist circumference were positively associated with total T3 and TSH. Each log unit increase in TSH level resulted in an increase of 4.57 kilograms per meter squared in BMI and 15.5 centimeters in waist circumference, respectively. In conclusion, it is known that the prevalence of obesity is increasing through time in the United States. Since the mechanism of obesity is still not fully understood, and the contributing factors are very diverse, the contribution of thyroid hormone status in determining obesity needs to be further investigated in a larger sample size.